Hello, my name is Marlene Kienberger, and today we will discuss what the circular economy is, which main product groups, respectively waste streams, are present, and how we can work with them. Then we will focus on plastic recycling and how hydrogen can be an enabler for sustainable plastic production. Here you see the concept of a circular economy as defined by the European Parliament. The vision is to restructure economy and society to a climate-neutral circular economy. A hierarchical order to achieve this goal is given by the 10R. The recycling of materials is the lowest hierarchy. It includes the recycling of materials and the recovery of materials by thermal utilization. The next hierarchy can be summarized by extended life of products, compounds, and infrastructure. Reuse, refurbish, reprocessing, remanufacture, and repurpose are contained here. And the highest and also most difficult hierarchy can be summarized under the headline Intelligent Use and Production of Products and Infrastructure. Here we should refuse, reduce, and rethink products. Talking about products leads me to the main product groups. Here, the European Union focused on 7 central product groups, where the most resources are used and where a high potential for circularity is given. These 7 groups are electronics and ICT, batteries and vehicles, packaging, plastic, textile, construction and buildings, and for sure the food sector. Today we are going to focus on the role of hydrogen in plastic recycling. It is clear that hydrogen plays a major role for other production paths, such as the steel production and recycling, but this is tackled in another lecture. Let's have a look on some facts and figures. In the European Union, 150 kilogram plastics are used per person and year, which results in about 20% of the chemicals emissions of the European Union. You see here the distribution of plastics in building, household, and so on. The by far largest proportion is related to packaging, and this is also what we will focus on. Plastic waste mainly undergoes 3 pathways: recycling, incineration, and landfill. With respect to the circular economy, we will have a closer look on plastic recycling and the role hydrogen will play here. This slide gives an overview of the ways of plastic recycling. The route that plastic needs to undergo mainly depends on the purity of the fraction to be treated. For example, mechanical treatment needs high purity of the plastic waste. After collection, the plastic waste is sorted, shredded, respectively grinded, washed, and dried, and the produced flakes are directly fed back into the processing route. All other recycling technologies require chemicals and degrade the polymer in the maximum down to the monomer. Further, a small proportion of plastics still will be incinerated, which brings the need for carbon capture and utilization technologies at the same time. Further, you can see that the main input materials are fossil resources, and exactly this is where hydrogen comes into place. Especially for plastic production, hydrogen can be the enabler for sustainable production. As discussed in previous lectures, green hydrogen can be produced from renewables. Together with carbon capture, CO2 can be converted to precursors or polymers. As platform technologies, microbial synthesis, electrochemical synthesis, or thermocatalysis play a role, whereby thermocatalysis has the highest relevance. The take-home message for you should be that hydrogen can be the enabler for sustainable polymer production. In conclusion, I showed what the circular economy is and which principles are defined for sustainable development. Further, the main product groups were defined, and then I gave a short insight into some facts and figures concerning plastic and plastic recycling routes, also focusing on the input material. And at the end, I showed that hydrogen may be the enabler for a sustainable plastic production.